Hi, everybody. My name is Joe Michaels. I am the Senior Global Vice President at a company called 1HMX. You may not have heard of 1HMX. It's a new brand for our company. You may know us by our product, Haptex Gloves. This is a product we've been making for many years. It's certainly one of the leading gloves in the market for teleoperation. And I put my email address up on this slide because I would love to be in touch with you. I love to get to know people who think like I do. So today, what I want to talk about is what I call the inconvenient truth about robot and human dexterity. And let's see if we got this working here. Nope, I'll just hit that. Okay. I want to start with a little wisdom from one of my favorite self-help gurus. This is a guy I used to love, Dr. Wayne Dyer, may he rest in peace. He helped a lot of people who were going through life crises, okay? And he would help them dream big. And he would, once he wrote, begin with the end in mind. Oh, can I use that? Okay, begin with the end in mind, start with the end outcome, and work backwards to make your dream possible. Okay, dream big and work backward. Now, I think that is a good strategy for someone who's going through a life crisis. But when we're talking about something as important as training and scaling physical AI in robots, I'm not so sure it's a good strategy. Let me give you an example. Some people have the dream of training physical AI through video and observation alone. Okay? They want to be able to show their robots hundreds of thousands of hours of YouTube videos, or perhaps teach the robots to do physical skills through observation, through egocentric video, and they're dreaming that this will enable the robots to do sophisticated tasks, sophisticated work. Now, those of you who are familiar with egocentric video will know that you're essentially acting as the robot's eyes, and you are looking at the tasks that you want to teach the robot to do. And this is the process of building egocentric video data sets will teach the robot how to do this stuff. And this is supposedly a superior egocentric video because it has what they call visible hands. The fact that your hands are visible in the scene is what is supposed to teach the robot how to do these complex physical tasks. Now, this concept has really caught fire with a lot of humanoid robot companies in the industry. And if I understand them correctly, this is what they're saying. If we show our robots enough egocentric video, enough visuals, and then we place these robots in enough physical environments and let them practice what they've seen, over time, we'll be developing these massive VLA models. And again, we're not just teaching the robots process or teaching them intelligence. We're teaching them how to do the things they need to do, okay, through observation alone. This, to me, and it may strike some of you the same way, is a little bit reminiscent of something called the infinite monkey theorem. Okay, this was an idea from a French mathematician about 100 years ago. And he postulated that if you put enough monkeys in front of enough typewriters and let them tap the keyboard at random, they will surely, over an infinite period of time, produce a work of genius like Shakespeare's Hamlet. Okay? If it sounds a little bit far-fetched for you to train robots to do difficult, complex work through video alone, that's because that's running up against and bumping into what I call the inconvenient truth about dexterity, which is that robots and humans do not learn how to do complex, dexterous work through observation alone. We must use touch. We must use our sense of touch in order to learn how to do tasks. All the YouTube videos in the world, all the egocentric video in the world cannot properly teach robots or humans to do difficult physical tasks, okay? NVIDIA expresses it this way, which I think is great. They're trying to get to scale with their models and their data for robot behavior. On the left part, the leftmost circle is internet video pre-training, okay? So they start with that. And they want to scale all the way to the post-training mass. You see how big that circle is? That's scale. That's what they're looking for, okay? Synthetic data generation. But look what's in the middle. Look at the missing link between the internet video and success in task completion on the right. It's human demonstration. Humans showing the robots and the models how to do the work, ideally with touch, okay? Some people might be out there saying, how important really is touch to a dexterous robot, okay? Now, I'm not talking about a two-finger gripper. I'm talking about a 5-digit robot, which is what we all want. How important is it? Well, let me just show you a little experiment that was done in Sweden, where the researcher asks the subject to perform a task. They say, would you please light a match? And look how easily she does it. Now the interesting part of the experiment comes. This is where they're going to remove her sense of touch. They're going to inject an anesthetic directly into the poor woman's hand, and they're going to allow her to retain her sense of muscle control, but she will lose her ability to touch the objects. Just take a look. That is 5 fingers of alleged dexterity trying to do the work without touch, okay? And it's no wonder, because, and you've heard this ad infinitum through some of the sessions, you know, over the last 24 hours or so, but the hand is a remarkable feat of engineering. All the bones, all the muscles, tendons, ligaments, blood vessels, lymphatics, you name it, it's packed into your hand to make it an incredible machine for touch feedback. And this doesn't even show you the most interesting component. The nerves and mechanoreceptors, this is wild. There are 17,000 mechanoreceptors, which are effectively the sensors of the skin, the sensors of the body, okay? All these different types at different depths beneath the skin, working together to gauge skin contact, deformation, texture, vibration, temperature, all this stuff, and it's giving you that acute sense of touch that we rely on. So, back to robotics. Okay, the Wall Street Journal writes about it, and they say armies of humanoid robots are waiting, they're poised to march into the world's factories. But before they can turn a wrench, they've got to solve what Elon Musk calls the hands problem, which is holding back the humanoid revolution. I know you've all heard this, but it's worth hearing it again. One of the big issues is Moravec's paradox, okay? What's easy for a human is hard for a robot, and what's hard for a robot is easy for a human in many cases. This is the best example. It's so easy to understand. Imagine giving a human, putting an egg on the table in front of them, saying, please pick this egg up and pass it back and forth between your hands, and don't break it. And it is insanely easy and automatic for human beings because of all the stuff I just mentioned with the hand, okay? They're just great at it with those mechanoreceptors firing away, okay? The tactile feedback tells you the curve and the shape and the location of the object. The force feedback lets you grip it the right amount. There's shear forces, vibrotactile feedback, thermal, all working together, so you just do it. Now, I want you to picture, if you place an egg in front of a bimanual robot, even one with 5 digits on each end effector, and you say, robot, pick this egg up and pass it back and forth between your hands without breaking it. How many hundreds of eggs do you expect will get broken while that robot figures out something that humans just know how to do? It's a lot, okay? So I want to get to this very important point, which is a little bit of a hot take. The best method for conveying touch to robots and teaching robots how to do difficult tasks is this word, teleop. This is a word that has been getting dragged through the mud, okay? When it's used to fake autonomy, when it's used to deceptively, sure, on social media it's going to get killed. But my hot take is teleop is not a four-letter word, literally or figuratively. Teleop is how many? 1, 2, 3, 4, 5, 6-letter word. But it is the way for us to convey touch to robots and teach them how to do the kinds of work tasks that we're all expecting robots will do. When we graduate beyond the two-finger grippers, which we're all going to want to, this is how we're going to get there, okay? And we've been doing it for a long time. My company created haptics gloves. It started on it in 2012, and in 2019, we did an experiment in Tokyo with our Japanese sponsors, and the test we put ourselves to was, could a human operator wear a blindfold and reach out and interact with an object dexterously and capably without even looking at it? And when we were able to do that, we realized we were onto something with haptics involved in the teleop. Now, fast forward to today, and you're going to see haptics gloves controlling a simulated and then a real robot from Sanctuary AI, our friends. And this is now a closed loop interface between the human and the robot, okay? Where you have tons of data points all feeding the robot and teaching it how to do the work. You have 36 DOF hand and wrist tracking. You have detailed pose data, skeletal and joint. You have 135 different points of tactile feedback on each hand. You have up to 8 pounds of force per finger. All of this is driving the robot, and it's creating this wonderful loop, this wonderful feedback loop. It's like a virtuous cycle. Basically, the human hand is directing the robot. And data coming off of the hand is improving the performance of the robot. And then what the robot hand senses is being fed back through data to the human hand, and it continually improves the performance. That's how you do teleop of dexterous activity. So let me just give you 3 ways I think teleoperation is awesome and will be useful. I think 2 of them you're aware of, and 1 you may be less thinking about. Here's the first one, the easy one. It's remote control of working humanoids. You don't always need autonomy. Sometimes you just want a robot in place, could be a dirty, dangerous, difficult place, and the human needs to bring their human intelligence, their human dexterity, their human decision-making to the job. Here's another shot of haptics gloves doing this for Sanctuary AI's Phoenix. Here's one you may not be thinking about. I call it rescue. Temporary teleop. As we start adding humanoids to the workforce, they are going to bump up against their natural limits of autonomy for the next decade, is my guess. And what are we going to need at that point? Well, you know what happens when you're in a Waymo, I presume, and you bump up against a dead end, and the car's autonomy can't figure out what to do? Well, a human operator just jacks in, gives you a U-turn, gets you out of there, and then the human goes back to their day, and you go back to your autonomous ride. The same kind of thing is going to be vital for humanoids, and teleop with haptics will be the answer. And then, of course, I think the most promising and exciting thing that teleop does, which is generate that data and teach the robot models how to do the dexterous tasks, not just the intelligence of what they should be aware of, but how to actually finish the job. That's how, haptics and touch will drive teleop to make robot physical AI better and better. So I just want to close with a prediction. I believe that as bipedal robots become more common, work that the robots do will change. You won't have just robots fixed in place, turning left to right. You're going to expect the robots to move through the world and do their work while in motion. As such, I think teleop needs to evolve. It needs to change. It needs to become less focused purely on the hands, which it has been for obvious reasons, and it needs to become more mobile. So, this is my first real sales pitch of the day. This is something that 1HMX has introduced over the last month or two. We're very excited about it. It's getting a lot of attention. This is called Nexus NX1, and it is the full body teleoperation system for humanoids, especially bipedal humanoids. The idea is to combine realistic touch devices and mobility technologies to let you really embody yourself in the robot and teach all aspects of it. This is what it looks like in use. This is the founder of Hapdex, Jake Rubin, and you see that he's wearing Hapdex Gloves G1 for the most realistic touch, and we built it into a Virtuix Omni One treadmill for safety, and for natural mobility, they're the free aim motorized shoes. It's an amazing combination. Then when you bring 72 DOF body and hand tracking into the picture, you are really retargeting every part of your body to the correct motions of the robot and vice versa. And that is a powerful way to steer teleoperated humanoids. And there's lots of new data categories coming off of this thing that will be fed into models and make them better and better. So in summary, I just want to say, if you try to dream big and work backward when you're talking about physical AI, and you try to shortcut and teach robots how to do difficult work without the right touch and mobility technologies, you're at risk of breaking a lot of eggs, breaking a lot of dishes, and maybe even some careers. So word to the wise. I would be delighted to answer any questions, and thank you very, very much.
Thank you, Joe. We have time for 2 questions. Okay, let me give you the microphone.
Really appreciate everybody coming down here. This is a cool space. Thank you for coming. Go ahead.
So I think one of the variables in the whole sim to real gap that you talked about is, especially in the dexterity part, is the combination of the sensor and the material that you choose for the skin, right? So what's your approach today, and how do you see that evolving in terms of closing when you're doing that simulation? The approach from your side is more like pick a specific combination of the sensor and the skin and then do an optimized model for that? Or is it like a general purpose model that you do with a standard set, and then the OEMs optimize it?
Yeah, good question. There are so many dirty little secrets, I think, to kind of how you make, good teleoperation happen. One of them is absolutely the quality level of the sensors on the robotic end effector. Without, you could have the best robot hand in the world, and if it doesn't have capable sensors that can map to a powerful glove like ours, what good is it, really? So we try to be agnostic, and we have an API that lets you connect our gloves to whatever sensor you're using. But if, we have 135 different points of feedback. If you've only got 1 to 10, areas of sensing on that robot hand, it's not going to give you much power and strength. So we suggest high-quality sensors. I can give you a number of names from Sensible to TouchLab to many of the others that are making sensors. I'm sure China will make some really exciting ones, and put those to work. And I'd be happy to talk to you later about more. Yes, please.
So thank you so much, Jun from Touchonics. So we are a tactile sensor company in Buffalo, New York. So actually, just have a follow-up question for that gentleman. Basically, a lot of our customers are actually from manufacturing, from East Coast, and we are kind of doing the things from another way. So they're trying to learn the data and experience from the human, and then trying to transfer that to a robot.
Yes.
So in that case, a very common, challenge we have is that, no matter how sophisticated our sensor is, there's always like different curvature and, elasticity of different people's hands, right? And then apparently that is very different from the, for example, the rigidity and the surface curvature of a robotic hand.
Oh, sure.
So I think so I would like to get your insight about how to bridge that gap, because apparently that is probably a physical challenge to bridge the thing to rail gap, right? So that's just some of my
I
questions.
think the retargeting of human movement to robots is a really new and an important challenge that we're all trying to address. On the list of problems, though, that we've had to solve and that are ongoing issues, that's way down the list. Is mapping the motion of the fingers to the correct motion of the robot, and even to the level of the sensors on the end effectors versus the size and shape of your hand. That's a lot less challenging than getting the motion of a bipedal robot, as it moves to match the motion of your body. We've been doing teleoperation for 6+ years, and that's not been a big issue for us. So I think it may be something, maybe we could talk after, but I think we've licked that one relative to some of the other fascinating challenges.
Thank you so much, Joe.